Morning to all of you guys in Australia. I'm Weixuan and I also go by Demi. And so this is the presentation for my paper. So overall, I got my inspiration for this project from my fencing experience during the pandemic. And I would say probably, we'll probably all agree that like the pandemic changed our lifestyle a whole lot, that everything just went online virtually. And that so for us fencers, the way that we have to work with that change a lot. So essentially like my fencing just went from like fencing in person to just watching the videos down there. Now it is a very effective way to learn for us, but I can show you guys like this quick video of like how 1 point in saber fencing would go. As you guys can see, this whole thing happens in like less than 2 seconds. And that for a lot of beginners or less experienced fencer, that is a big problem. They cannot catch what is happening. They are like having trouble like focusing just because they don't know the content at all. They don't have that experience to help them capture the important details in the video like this. So in order to like help them with that, because well, learning from these world-class fencers is like a really good way to learn, I just decided to like help them with my with like artificial intelligence. So well, overall, this program takes in a video and output strategies and the result of a point. And so overview for this entire program, so there's several parts in this. The processing video so that the video can be analyzed to capture fencers' motions and analyze the point and technique. So for processing videos, this program uses OpenCV library so that we can split up the video by frames and then like passed it into our later algorithm for further analysis. And so, well, before using, we capture the fencer's motion using pose estimation. So before I tried that, I did try things like background removal, which is a pretty developed, in a way, rather old artificial intelligence algorithm. It didn't quite work in this scenario because a fencing clip can have like different lighting. Sometimes the camera is not so stable. Sometimes the camera can be zooming in and out. And those are big no-nos for the background removal. Any bit of moving from the camera itself will create a whole ton of noise for the for our result. So in order to capture fencer's motion, we choose to use pose estimation, which in this case we get our functions and all that from OpenPose. And so the analyzing fencer's motion part, for that part, I actually developed my own algorithm. So it is possible to use deep learning or neural network for it. It's just that most of the similar projects that I found out there doesn't achieve the same effect that I wanted it to, because most of them are able to give me a result, but not able to tell me the certain strategies being used in a clip. So so in order to like to recognize the strategies, whatever the people are doing in a clip, I have to develop my own algorithm. And so here is a quick demo for pose estimation. I picked this quick clip and the skeleton being drawn on there is representing the pose estimation. So essentially how pose estimation work is that it would find those key points on a human body. So key points would include things like their head, shoulder, elbow, wrist, knee, hip, foot, things like that. So and the lines drawn on there are just connecting those key points that are being detected so that we can simplify a human into a skeleton like this. And so the actual procedure of my entire program is that like I first used computer vision instead of OpenCV split up every video being passed into like frames. And then I set up the post estimation so that it can detect the key points. I also need to process those key points so that so sometimes we have more than two people, more than just the fencers being captured by our algorithm, and we need to just we need to dispose those frames because we want the fencers only. So I did set up algorithms to check if these two set of points are on roughly the same horizontal coordinates. And if they're not, then these frames would just be disposed and we will not be using them for our analysis. And so for analyzing, there are like a whole lot of things into it. So I'm going to be focused on like one of the methods that I was using. Since fencing, well, you know, most of the sports in real life, they works in 3D, but in here in a video, we're only getting information in this 2D format. So the way that we approach this is that we have to find some way to detect when a fencer touches the other fencer using the blade, because this is how a person can get a point. And so my entire algorithm is developed based on the assumption that as long as two fencers are close together, an attack will happen. This assumption is made based on my experience with fencing, because even for fencers like me, I'm not very experienced, but if I'm close enough to my opponent, something would happen. Either defender would do something or the attacker would do something. And this entire program is made for higher end fencers, well, to analyze videos of those higher end fencers. So we're assuming that they wouldn't make like beginner mistake like that they would take their chance whenever the distance is close enough. So while getting the distance in between two fencers are easy enough, we'll just get the coordinates of their wrist and the coordinates of the other fencer's shoulder to hip-ish area, and we'll draw a line there, and that would be their body. So now we would just need to get we would need to know whatever distance that is in between the wrist and the body so that we can like detect what is going on there. So the value that we set for the distance there is the value for the blade length. Now you might ask, how do we know the blade length? Because I do know the blade length in real life, but because of different resolution of the videos, it is not guaranteed to be the same amount of pixels every time. So there is one thing that we do know, that if we look at one of those videos like this, that the fencers, they're on a big, this video doesn't seem to work. So if you guys can see it on the on the first demo there, videos work on lines on where the fencers are supposed to be starting from. And because of that, is 4 meters by the rule. And from there, we know that the blade is 88 centimeters long, set by the rules. And so just with some simple algebra, we can like calculate the amount of pixels that we should start to be alarmed and like start to run the whole algorithm to see our strategies when the two fencers is within that 88 centimeters distance. So, well, and so by doing that, we essentially is like able to go over the fact that blades is like really, really hard to detect in a video. Because they're really thin, and because of different lightings, sometimes they're almost invisible, and sometimes when they're moving fast, you wouldn't get one thin line there. So this is just one of the many methods I use to achieve my goals. And yeah, thank you so much for listening.